All right, so we have briefly touched on drop swap and writing formulas for ionic compounds, but now we're adding a new layer, and that is with the transition metals. Remember, with transition metals, we don't know their charges. They break our rules, and so we need to figure out their charge a different way. When we're given the name of an ionic compound with a transition metal in it, we are given a Roman numeral that tells us the charge of the transition metal. Remember that metals are always going to be our cations, so we know that that's a positive charge. So I want to write the chemical formulas for these ionic compounds. I know they're going to be drop swap, but I have to set up my correct charges. So chromium is Cr, and we know, that it is going to be a 2+. Chloride comes from chlorine, that's Cl, and that's a 1-. So then I'm going to drop swap, and that is going to give me a formula with 1 chromium and 2 chlorines. Now let's do the next one. Rhodium 4 sulfide. You'll start getting really good at reading Roman numerals. Rhodium is Rh, and from the Roman numeral, we're told it has a 4+ charge. Sulfide comes from sulfur, that has a 2- charge. So now I'm going to drop swap. But remember, ionic compounds, we reduce like fractions. So even though we end up with Rh2s4, we can reduce that by dividing both subscripts by 2. So the correct answer is going to be RhS2. Now this last one, titanium 3 oxide. Titanium is Ti, and we are told it has a 3+ charge. Oxide comes from oxygen, which is 2-. And then when I drop swap, I'm going to get a formula of Ti2O3. So that is going from name to formula using drop swap and reading the Roman numerals. But let's try the next one. What about we know the formula, but we want to figure out the charge of the transition metal? This is going to cause us what we call reverse drop swap. The way I figure these out is I can either just reverse my drop swap, or sometimes I have to double check with my anion, with the charge of my anion. And so if I look at Fe2O3 and I reverse my drop swap, I know that that means my oxygen has a 2- charge, and I know that that also means that my iron has a 3+ charge. So then this would be iron 3. And that is the charge of my transition metal. The way I double check that, though, is I have to look at my anion. Does my anion here have the charge I would expect it to? In this case, yes, oxygen is a 2- charge. So now I'm going to try it with CuO. There are no subscripts, which means each of these are 1s, so I'm going to reverse my drop swap. And that would give me a Cu 1+ and an O1-. However, I double check. This is not what I would expect the charge on oxygen to be. So I have to figure this out a different way. I can't just reverse drop swap. The way I set that up is I know my oxygen is going to have a 2- charge. And in my formula, I have one of them. So I multiply it by 1. That means my total negative charge is 2-. Now remember that an ionic compound has a net charge, an overall charge of 0. So with this 2- charge, whatever my positive charge is, it has to balance out a total positive charge of 2+. 2+. And so what that means is that with my copper, whatever charge it has, which is unknown, when I multiply it by the number of ions in the compound that I have, which I know is 1, it has to equal 2+. From here, it's a simple algebra problem. 1x equals +2. I divide both sides by 1, and I get that X equals positive 2, or 2 plus. So then this is a copper 2 ion. So now let's try the last one. First, we start with a reverse drop swap. This 2 comes over here, so then I get a nickel 2 plus. There's 1 nickel that goes to the sulfide, so then it would be an S1 minus. We know that we should have a sulfur 2 minus, so this is incorrect. And now I have to set up my little algebra problem instead. So my sulfur, I know it has a charge of 2 minus. And in my formula, I have 2 of them, which gives me a total negative charge of 4 minus. Now with my cation, I know I have to have a total charge of 4 plus to get to that overall 0 net charge. I only have 1 nickel, and its charge is unknown. And so now I do algebra to solve for my charge. 1x equals 4 plus, divide both sides by 1. That means that x equals positive 4, or 4 plus. So this is a nickel 4 cation.